Hey guys, Tori here from Overlook Horizon. Welcome back to another rocket launch. This is Space Lobster Nation After Hours here because it's after midnight my time, almost 1 o'clock in the morning. Getting a little sleepy-eyed. I can see it in my monitor here already, but we're gonna try to stay with it, and we're gonna try to get a nice early morning, late night launch here. West Coast launch. I haven't had a West Coast launch in forever, and this is kind of a this is like a regular satellite launch. We also haven't done one of these in quite a while. So here we are for some regular space launch action here. So we can kind of jump right into it right away here. This is a live look right now of the Falcon 9 rocket over at Vandenberg Air Force Base on the West Coast over California country. And we're going to be launching a West Coast launch. We don't see a ton of those. West Coast launch pad is generally for retrograde orbits, which we almost never see, or polar orbits, which we do see. Previously, they were the exclusive area for polar orbits, before recently SpaceX kind of reactivated the polar corridor for the East Coast, for Cape Canaveral. They only just recently started doing that here within the last year or so. I can't remember when they actually, how long it's been since they started that, but just recently. So yeah, this used to be the only place where we would launch polar orbiting satellites, and this is going to start in a polar orbit, but obviously today is the DART mission, NASA's DART mission. DART stands for the Double Asteroid Redirection Test. Essentially, they're sending a satellite out to a pair of asteroids, one that's orbiting another, and they are going to smash it into the asteroid at like 15,000 miles per hour and try to redirect it. Now, they won't have a ton of redirection, right? Like, it's not like it's going to send it, from the orbit of Mercury out to the orbit of Pluto. It's just a small redirection, right? So the current orbital period of that asteroid, that's, and I got to remember the names of each one. Let's see, what were the names of them? There are two of them, and one is Didymos. I'm probably just butchering the name of that. Didymos, Didymos. Help me! Don't just stand there. Help me. And what's the other one? The other one also starts with a D. I can't remember the name of it. Now I can't find it, of course. What's the other satellite's name? Or not satellite, asteroid. But anyways, the current orbit, while I'm looking for this, the current orbital period of the moonlit satellite is 11 hours and 55 minutes. Let's see. Somebody's gonna help me read the chat. Dimorphos, Didymos, and Dimorphos. Yeah, right. So anyways, the current orbital period of the smaller one that's going around the bigger one is 11 hours and 55 minutes, and they're trying to change that to 11 hours and 45 minutes. Tiny change in the orbital period. But the idea here is that they are going to try to get this to test whether they can redirect asteroids with kinetic energy, with an impact like this. And the theory is that if you do it early enough, like, it is just a small change, but if you detect an asteroid that's going to collide with Earth or something like this, this is a test of our Earth defenses, so to speak. So if you detect it early enough, send a mission like this out there and do this redirect early enough, you only need a small kinetic change to get it so that it doesn't hit Earth, right? You don't need to just blast it, out of the galaxy. Just need a small little change. And so that's kind of what they're testing here today is, well, they're launching today. It's going to take 10 months, I think, to get to Didymos. Everybody's correcting me on this saying. I listened to it. I listened to the press conferences like 45 times earlier today trying to make sure I could say it right. And then come showtime, I just can't do it. It's 1 o'clock in the morning. Like, come on. Can't they just name them like Bob and Jane? Like, I don't know. Give me something easy. Why didn't they ask Bruce Willis for help? Says William. Right? Where's Bruce when you need him? So we're counting down here. We're gonna kind of rifle through it a little bit. SpaceX will be live in a bit. NASA's already live. They're already chatting it up here, but I'm gonna stick just to kind of the live views, right? We all want to see the rocket. Show the rocket. That's what we want to see. So we're gonna just kind of keep an eye on the live view of the rocket here. So. And I'll get to your chat here in just a second. I see everybody saying hello. Of course, everybody that was helping me with the pronunciations of Didymos. Yeah, the names Bob and Doug are already taken. So I know I was gonna say Bob and Doug, but I was like, yeah, we kind of already did a Bob and Doug thing. So let me. Let's go through a couple of our of what we're talking about here today. So obviously we've got the timeline that's over here on the what is that? Your left-hand side of the screen when you're watching here. So that's going to count us down all the way to 0 when we launch. Obviously, it's pretty close, but we'll kind of keep an eye on this to see if we can update it to match their timeline once we see that here, which we'll get access to from SpaceX here shortly. Looks like they're live already, so we should be in good shape soon. And we'll switch to the SpaceX feed in a bit because SpaceX is at 10. Actually, they're streaming at 4K, and the best I've got here from the NASA feed is 720. So that's unfortunate, but at least we'll get like 1080. So. Anyway, so keep an eye on the events list there if you want to know what's going on here. Right now, they're fueling the rocket. They started that a few minutes ago, so this is an instantaneous launch window today. So if they have to scrub for any reason or have to hold for any reason, it will be a scrub for today. So as I mentioned, this is over at Vandenberg Air Force Base, way out here. Here's Vandenberg. Here's the launch pad at Vandenberg. Going to be heading to the south here, right? Heading off to the south. We'll be under powered flight for stage 1. We get cutoff and separation right here. Stage 1 is going to continue on, land on the drone ship. Of course, I still love you. Out here in the Pacific Ocean. Drone ship landing in the Pacific Ocean. We haven't had one of those in a very, very long time. And the second stage will continue burning up here. Kind of make a little bit of a dog leg maneuver to go even more like south-southeast kind of, and head on into this polar orbit. Then once it's in the polar orbit, we'll get a second engine burn about 30 minutes after launch, and then finally we'll get deployment about 1 hour, about 55 minutes after launch is when we're expecting deployment. So that's the plan for the actual launch here for today. Just to give you kind of another map view here. This is showing our little hazard map here. So you've got the drone ship position, which is in blue, and then the NRC Quest is out here for a fairing recovery. So obviously we've got our fairings on board.
Stage 2 locks load complete.
They've kind of given up on the net catching, the Mr. Steven, Miss Chief, Miss Tree
Stage 2
boat.
RP1 load complete.
They've kind of given up on that, and they're just going to pluck them out of the water. So NRC Quest is out there to recover that. And then obviously here's our launch site hazards as well. Occasionally, here's this is Launch Complex 4 here, Vandenberg Air Force Base, and then they've also got a landing zone 4 over here to the side right here. Occasionally we see them do an RTLS landing, but not today. So we're just launching here, and then we're doing a drone ship landing today. So that's the plan, and now we see a ton of venting going on here. All completely normal. We'll keep an eye on that. Weather, still looking pretty good. Oh, here's a little NASA animation that they're talking about here right now. This is the DART satellite, and our two asteroids. Oh, they switch back to the space station. That's not what we want. We can show that video a little bit later, but I was kind of hoping that NASA or SpaceX would show it for us. Weather is looking pretty good. All weather was in the green so far. We did have some winds offshore here, but nothing that was looking like it was going to threaten the actual ground level winds here at the launch site, which were under 10 miles per hour. So that's looking pretty good for our launch site. Let's see. Actually, we're going to back this up a little bit here. Then we'll look at upper level winds, just to give you an idea. A little bit quicker, but still not too bad. 50 miles per hour sounds like a lot, but it's not bad for the Falcon 9 rocket. Heading to the south, you can see it's pretty light, so no big deal here. Winds are looking pretty good. Up here, a little faster, 165 mile per hour upper level winds. That's a little quicker. You could have a scrub if this stuff was over the top of the launch site, but it's not. So we're in good shape. All right, let's see. SpaceX is now live.
A live view of Falcon 9 as it awaits its 10:21 p.m.
We'll turn them up here in just a minute here, and we'll get their telemetry and things like that on the screen here too as well. Switch to SpaceX 4K. Yeah, SpaceX. I will switch to them in just. Well, we could probably switch to them now. We got Jesse Anderson from SpaceX chatting it up here. Let's see. We'll switch to Jesse. I have her muted at the moment, but they're not showing the rocket, so we're gonna keep it on the rocket until at least for just a minute here. Well, let's see. We're gonna get rid of a couple of these windows that we don't need anymore. Let's grab a couple of questions. Can you see this from the ground? You'll be able to see the launch if you're in California. Anywhere from Vandenberg south, you'll be able to see it if you're looking out over the ocean, especially because it's a night launch. Yeah, near the coast of California, towards the southern coast of California. Definitely be able to see this. So keep an eye out to the sky here in about 16 minutes or so. We're pretty close on time for what SpaceX has as well. Do we have any images of the NASA DART? Yes, and that's what I was just about to pull up here. So the satellite itself is going to be about once it unfurls or unrolls its solar panels, is going to be about the size of like a school bus, I believe is what they said. So it's not a huge. Here, we'll just show the NASA website here real quick, because that'll probably be the easiest thing for me to show here. But we've got cameras on board, thrusters on board. They're going to be recording the whole thing, sending information back to Earth, obviously. But there's basically like the main sensor payload package in the center, and then two big solar panels that will kind of roll out on the side. So here's our big solar panels. You can see the thruster on the back of it here. But yeah, that's pretty much it. It's not a massive like stadium size satellite. It's like a stadium size asteroid that they're trying to redirect. So nothing enormous, but that's what the satellite is going to look like fully deployed. All right, let's get SpaceX is now showing the rocket, which is good news. Let's get our clocks. Let's synchronize our watches, because I'm a touch bit ahead of them. Should be something like this. There we go. Now we're synchronized, and there's our drone ship.
On your screen. Now, if you turn your attention to the section above the first stage and the black carbon fiber inner stage, you'll see Falcon 9's second stage. About 2.5 minutes into flight, the first and second stage will separate, and the second stage will ignite its single Merlin vacuum engine to carry the DART spacecraft to an interplanetary trajectory, as I mentioned earlier in the webcast. Separation from the second stage will occur, and then the spacecraft will perform burns as it begins its journey in space. Now, finally, above this stage, placed at the very top of the vehicle, you'll see the nose cone structure, and that is called a fairing.
Look at the cameras we got
Inside
today.
of that
This is a
structure
nice
is
one.
the DART spacecraft. The two fairing halves are safely encapsulating the spacecraft to protect it from aerodynamic heating, loads, and contamination during ascent. The fairing halves we are using today are brand new, and we plan to recover them on our recovery ship, NRC Quest. Now, once the vehicle reaches the vacuum of space, we will jettison the fairing halves as the second stage continues on its journey to orbit.
Good evening from Hawthorne, California. I'm
Hey,
John
John.
Isberger, the Falcon Principal Integration Engineer. And the launch vehicle and spacecraft are in good health and ready for launch as we approach T-minus 13 minutes, 30 seconds to liftoff. The Falcon 9 team reported on console at T-minus 2 hours, 15 minutes. We received the final countdown briefing from the SpaceX launch director, and we began the final checks of the launch vehicle and the ground systems. Final checkout of the flight termination system was performed at T-minus 1 hour, 45 minutes. Now, most recently, we completed the poll to proceed with propellant load and launch. Propellant loading is ongoing. We started it on time at T-minus 35 minutes. Now, Falcon 9 is a bipropellant vehicle, meaning it uses two propellants, a fuel and an oxidizer. For Falcon 9, our fuel is a refined form of kerosene known as RP1. Now, to burn the fuel, we need a source of oxygen, which we call the oxidizer. Most burning on Earth uses oxygen, which makes up about 21% of the air you breathe. However, in space, there is no atmosphere to provide oxygen or other oxygen-bearing molecules, so rockets need to carry their own. Falcon 9's oxidizer is super chilled liquid oxygen called densified LOX. The liquid oxygen is chilled well below its boiling point to increase its density, and that allows us to load more into the first and second stage LOX tanks. Now, currently, fuel loading is complete on the second stage. We're continuing fuel loading on the first stage up until T-minus 6 minutes. Liquid oxygen is loading on the first and second stages right now. Now, in addition to its propellants, Falcon 9 also needs an ignition source to start burning the fuel and oxidizer. And for that, we use the chemical T-tub, which stands for triethyl aluminum and triethyl borane. We ignite the engines by first flowing some liquid oxygen and T-tub into the gas generator and the main combustion chambers. The T-tub burns in the presence of oxygen. So once we get that ignition, then we can introduce the RP1 kerosene fuel, and the Merlin engine goes to full power for liftoff. Now at liftoff, Falcon 9's two stages combine to hold over 1.1 million pounds propellant. And we'll burn through most of that over the 8.5 minutes it takes to land the first stage and get the second stage into its initial orbit. Now, once our Merlin engines begin to burn the RP1 kerosene fuel and the liquid oxygen, you're going to see the rocket essentially throwing the combustion exhaust out of the engine nozzles in one direction, resulting in a push on the rocket in the opposite direction. And this is the great example of Newton's third law of motion. For every action, there is an equal and opposite reaction. Now, we started the day with pretty good weather forecast, and the good news right now is weather officers giving us a 0% probability of violating launch weather requirements.
0%, all right.
The ground level winds are good, the upper altitude winds are good, and we don't expect to have any weather holds for launch. The weather conditions also look good for booster landing on our drone ship and for fairing recovery in the Pacific Ocean. So with that, the launch vehicle, the spacecraft, the weather, and the range are all good to go for a 10:21 p.m. Pacific time liftoff from Space Launch Complex 4 East.
Liftoff of Falcon 9 will kick off a roughly 11-month journey for the DART payload. The DART spacecraft will separate right around 56 minutes into flight, and from there it will spend the next 11 months cruising to its intended destination, intercepting the binary asteroid system between late September and early October of 2022. DART's target asteroid is the size of 2 football fields. Impact will occur when the distance between Earth and the asteroids is near its minimum, within 6.8 million miles or 11 million kilometers of Earth. This will enable scientists to observe and measure the change in momentum of the Dimorphos asteroid.
Dimorphos.
And it's worth
There we
noting
go.
that Dimorphos is not a threat to Earth. Therefore, it's a perfect testing ground to see if intentionally crashing a spacecraft into an asteroid is an effective way to change its course should an Earth-threatening asteroid be discovered in the future.
Now, the DART demonstration has been carefully designed with 4 key objectives. The first objective is to demonstrate a kinetic impact with Dimorphos, the smaller of the 2 asteroids. DART will hit the asteroid nearly head-on, delivering enough energy to leave an impact crater, but not enough to destroy the asteroid, eject it from its orbit around that larger asteroid, or noticeably change the pair's orbit about the Sun. Now, the second objective is to change the binary orbital period
Not
of
sure what's happening
Dimorphos. Now, the orbital
like
period is
Joe
the time
Barnard.
it takes the smaller asteroid to circle the larger asteroid you can see here in the graphic. Currently, Dimorphos is in that original orbit. Scientists estimate the collision will shorten the smaller asteroid's orbital period by several minutes, placing it into that new blue orbit. Now, the third objective is to use ground-based telescope observations to measure the orbital period change before and after the impact. Telescopic observations in the weeks after impact will confirm that DART changed that orbital period of Dimorphos, and it'll reveal by how much. And then finally, the fourth objective is to measure the effects of the impact and the efficiency of that deflection. Now, choosing this binary asteroid target for the demonstration takes advantage of the fact that changes in that smaller asteroid's orbit around its larger partner can be more easily measured than the changes in a single asteroid's orbit around the Sun.
To ensure the best possible data capture, the DART mission is taking along some pretty cool technologies to help capture this demonstration test. On board the spacecraft is the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, also known as DRACO. Now, this is not to be confused with the Draco thrusters on SpaceX's Dragon spacecraft. DART's DRACO will provide real-time streaming images of the asteroid as it approaches impact. In addition to the onboard camera, the team is also flying a CubeSat from the Italian Space Agency known as LICIA-CUBE, which stands for Light Italian CubeSat for Imaging of Asteroids. This cube will be deployed from the DART spacecraft 10 days prior to impact with the asteroid. LICIA-CUBE will use its onboard propulsion system to alter its trajectory, offsetting so that it flies past Dimorphos approximately 3 minutes after the DART impact to capture the effects of the impact. Now, it's pretty incredible to think about what a mission like this could mean for the future of planetary defense. Now let's take a closer look at what the NASA team is hoping to achieve with the Double Asteroid Redirection Test mission.
All right, so they've got some music going here, but so I want to get to just to clear up a little bit of confusion on what the mission is, right? So they're trying to redirect an asteroid. This asteroid is not a threat to Earth. This is just a test for maybe someday when there is a threat to Earth. They're doing it around a binary asteroid system, 2 asteroids, one that is orbiting the other one, and that is so that they can more easily detect the changes that they make in the orbit around that other asteroid. It's a much smaller period to measure versus if you're making because they're only making tiny changes to the orbits. Like, it's not really a huge change, but if an asteroid is coming to Earth, you don't really need a huge change. Like, you detect it early enough, just kind of push it off to the side, so it doesn't crash into Earth, right? You just need a small little change here. And that's all they're going for. They're trying to essentially slow it down a bit, right? They're going to crash into it, slow it down, and so it's in a new orbital period around the main asteroid that it's orbiting. So that's it. That's really the idea. It's pretty simple. They kind of just crash right into it and try to change its trajectory or its orbital period. But what this is going to help for is to help demonstrate whether kinetic energy or collisions like this could actually be a viable option to change the orbit of an asteroid that may actually threaten Earth sometime in the future. So kind of cool technology. But When is liftoff? We're about 5 minutes away, actually. We're pretty close. Where is liftoff? Vandenberg Air Force Base on the west coast off in California. We'll be heading to the south. Let's see. Space billiards. Yeah, pretty much. They're kind of just crashing into it here, and we're going to move things around a little bit. So they're trying to change the orbit of these asteroids. Just one of them. They're just changing just the smaller one that is orbiting the bigger asteroid. The bigger asteroid is going to continue on in its normal orbit, and the smaller one is going to continue on with it. It's just the orbital period around the bigger asteroid will change, only by about like 10 minutes.
And counting, everything continues to be go for launch.
Meaning that it currently takes 11 hours and 55 minutes for it to go around the other asteroid, and they're going to crash into it, and they want to get it down to like 11 hours and 45 minutes. That's it.
Opened up, and you can see that the strongback has begun to retract away from the rocket. It's moving all the way back to a launch position about 77 degrees upright. Now this is different from Falcon East Coast launches, where we move the strongback only 2 degrees, and then we retract it the rest of the way at liftoff. It's slick 4. Once we get it back into position here in about another 40 seconds or so, we won't have to move it farther away at liftoff. Also, while we were watching the video, we have completed the fuel load on the first stage on time as expected, and we've begun chilling of the Merlin engines. Coming up on T-minus 3 minutes, everything continues to be go.
Stage 1 LOX load complete.
And we just heard that call out, LOX load complete. That is the first stage LOX loading being completed. Second stage will complete around T-minus 2 minutes. And Falcon 9 and DART teams continue to track no issues for launch. Weather is still looking great, as John mentioned. The range is ready to support, and SpaceX team is monitoring the completion of that second stage. Coming up next, around T-minus 2 minutes, we should hear LOX loading completing for that stage. Now, as a reminder, we do have, if we do have a hold on today's launch for any reason, we do have a backup opportunity tomorrow with a liftoff time of 10:20 p.m. Pacific time, just a minute earlier than tonight.
Coming up on T-minus 2 minutes, waiting for the call out that LOX load is in closeout.
Stage 2 LOX load complete.
So last big vent coming up at about a minute and a half. We'll see a big, huge vent of liquid oxygen as they drain the lines in the transport erector there. So we get a bunch of big venting here coming up.
Stage 2 LOX load complete.
In about 10 seconds.
There we go. Stage 2 LOX load is complete. This completes loading of the over 1.1 million pounds propellants on the Falcon 9.
The big vent.
All systems remain go for launch. Now the SpaceX ground computers are now draining propellant out of the lines that go up the strongback to the second stage, and that creates the white cloud that you see around the strongback. Pressure from the ultra-cold liquid oxygen line is being vented, and that causes moisture in the California night air to condense. Next event will be the startup call-out at T-minus 1 minute. The first second stage computers on Falcon 9 will execute programs to prepare the rocket for flight, leading to ignition of the Merlin engines at T-minus 2 seconds and liftoff at T0.
Falcon 9's in startup. Launch.
There's that call out. Falcon 9 computers are now running the final sequence for launch. First and second stage tanks are beginning to final pressurize for launch.
T-minus 30 seconds.
30 seconds.
Just waiting
Falcon 9 DART, go for launch.
Do I have two
and there's that final go
feeds?
for launch with all systems
I do have 2 audio feeds.
go for T0. Let's listen into the terminal count and watch Falcon 9 transport NASA's DART spacecraft into orbit.
I had 2 audio feeds going, so unfortunately I had to mute the other one. And we don't have the sound here. I don't know what to do.
T-minus 15.
Well, we'll listen into this one.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Falcon 9 with the DART mission on the way for humanity's first ever planetary defense test mission. Vehicles pitching downrange.
right, we lost our...
Stage 1 chamber pressure is nominal.
Nominal.
T plus 33 seconds. SpaceX launch engineers seeing a nominal conditions on Falcon 9 as we begin the trip to space carrying the DART spacecraft. M1D engines about to begin throttling down.
Power and telemetry nominal.
We're throttled down.
Max Q.
Avionics calls out good power on the vehicle.
Vehicle supersonic. Max Q.
So
We've gone supersonic. We're through the period of maximum dynamic pressure. And the Merlin 1D engines have throttled back up to full power. We're out of the throttle bucket. From here on, even though the velocity is rapidly increasing, the atmospheric density is decreasing, and so the loads are decreasing now on the Falcon 9.
Index chill has started.
Everything continues to look good with the stage 1 trajectory.
I got 2 audio feeds running and they're not...
Index chill has started.
There we go. Now they're pretty close to synced.
Lead valve is open on the second stage engine. That's beginning the final chill prior to second stage engine ignition. Two minutes into flight, all continues to go well. In 30 seconds, we'll have 3 significant events coming up in quick succession. We'll get MECO, main engine cutoff, where we shut down the 9 Merlin engines. The stages will separate, and we'll get ignition of the MVAC-D second stage engine to power DART and the second stage into their parking orbit.
All right, once we get into orbit, I'm going to replay it, but from the other feed that had the better audio.
We've throttled down to hold at 4 Gs, getting ready for MECO.
There we go, coming up on MECO. Should be right here. MECO.
Stage separation confirmed.
Boom. Watch the stiffener ring break off of the engine bell here.
Index ignition.
Right, there it goes. See you later.
We've got successful stage separation. Second stage engine ignition now at full power on the Merlin engine. Next event coming up is going to be payload fairing jettison. On the left side, you can see the titanium grid fins on the first stage beginning to deploy as we get ready to bring the first stage back down to the drone ship, Of Course I Still Love You, in the Pacific Ocean. Getting ready now. There's
Fairing
the view
separation confirmed.
Pairing set. Look
of
at
the
this.
fairing.
Yeah.
And we've got deployment of the payload fairing, and now the DART spacecraft exposed to the vacuum of outer space. Now, we will be attempting to retrieve these new fairing halves with the help of our recovery vessel, NRC Quest.
Stage 2 on nominal trajectory.
All right, booster coming
Everything
back.
going well with Falcon 9 and DART.
So remember, the booster is still...
What you're looking at on your screen is a live...
Booster's still climbing right now, so the booster continues to climb even though there's been separation. The booster continued to climb for about another 30 seconds or so, and then it starts coming back down towards the drone ship.
At T plus 6 minutes and 40 seconds, you should see on your screen, hopefully we'll get some live views of the first stage entry burn. And that entry burn will last about 30 seconds. Now for the entry burn, we do relight the center E9 engine, and then partway through we relight the E1 and E5 engines, so that we have 3 total M1D engines helping to slow the vehicle down as it passes back into the Earth's atmosphere.
All right,
Again, what you're looking at on your screen is the MVAC engine on the second stage. We're getting some awesome live views.
Looks like we got
And
apogee right
everything is
there for the
still
first
looking
stage
nominal
booster
for
now.
stage 2.
Speed starting to increase, altitude starting to decrease. So that's about, I think that's right there is apogee. So now the booster's coming back down. Here comes the altitude coming down on the booster.
At T plus 5 minutes into this mission, we're just under 2 minutes away from the entry burn on the first stage, as second stage is continuing on its journey. Again, this is the first of 2 planned MVAC burns for this mission.
Yep, so entry burn still coming up. We still got another minute and a half here till we get to entry burn.
Now the Falcon 9 booster supporting...
Entry burn is really gonna, somebody said entry burn, question mark. Entry burn's gonna slow it down, but as it comes into the atmosphere, just so that it doesn't heat up too much, doesn't break apart. So it's coming back into the atmosphere. So they need to do that entry burn to slow it down in order for it to come back in one piece. Tori, will you explain the term apogee? Yeah, apogee is just the highest point in its ballistic trajectory. So if you think about like throwing a baseball and it's got a kind of an arced path, the highest point of that arc is apogee, and then it starts coming back down. So basically, the rocket, when it lifts off, it's just in a ballistic trajectory, just like throwing a baseball or something. It's in this arced path, and it goes up, and then it starts coming back down. And the idea is for the second stage is also in that arced trajectory, but if you start going faster and faster and faster, eventually that arc gets so fast that the part where it comes back down is past the Earth, and it just continues to miss the Earth as it keeps coming back down, and that's orbit.
These do achieve 190,000 pounds of thrust during ascent and descent. And it looks like we got a live view on your left-hand screen of the first stage.
Looks like we're getting entry
Stage
burn
1,
startup.
FTS is saved.
There we go. There's entry burn.
And we heard the call out as well as visual confirmation that the entry burn has begun on the first stage. Again, this is about a 30-second burn and just helps to slow the vehicle down as it's re-entering the denser part of the Earth's atmosphere.
Stage 1, entry burn shutdown.
And as you could see, the engine shut down on your screen. We did hear a call out that entry burn is complete.
Stage 2, FTS is saved.
There we go. Stage 2 FTS is saved.
Stage 2 continues on a nominal trajectory.
At speed still climbing for the second stage, 22,000
coming
kilometers
up
per hour now.
In just
Terminal guidance.
a little over a minute will be SECO 1. That is second stage engine cutoff 1. Again, there's 2 burns for the MVAC engine on the second stage, so we are in the first burn.
Expected loss of signal, Cook.
So we should see this engine shut off here shortly.
Where's the booster? Show me
About
the
20
booster.
seconds later, we'll see or hear the landing burn call out on first stage begin.
Booster's at 6 kilometers.
MVAC shutdown.
Here we go. There's SECO for stage 2. Stage 2 is shut down. We're at 3 kilometers for the booster. 900 kilometers per
and
hour.
we just
Nominal
had,
orbit insertion.
that's what we were
There we
waiting
go.
for.
Stage 1, landing burn startup.
Here we go. Landing burn. Show
So
us the
we
booster.
got SECO 1
Come
on
on, I wanna
second
see it.
stage. We got a confirmation
There
of
it
good
is.
orbit, and the landing burn
Land
has
it.
begun on first stage, and now we have a live view of first stage making
Where's the
its
drone
way
ship? There
to,
it is.
Of course, I Still
There
Love
it
You.
is.
Stage 1, landing
Oh,
leg deployed.
it's a little off center. Bring it back in. Bring it back in. I think it was coming back in. Oh, no.
And we had some incredible views. Now we're just waiting for some confirmation of that first stage
Hawthorne
landing here
proxy.
in a second. As we have a live view of second stage currently with the engine cut off as it's coasting towards its targeted orbit.
Well, did it land? I'm sure it landed. It must have landed, right? Nothing? No word yet.
And we will wait for that confirmation of that first stage landing, but
Come on.
you have just witnessed Falcon 9's 26th flight for this year. And we will confirm once we have that confirmation for that first stage landing. So now at this time, our mission isn't over just yet. The second stage is now embarking on its first coast phase. Coasting in this orbit will last about 20 minutes, and we will light that MVAC engine for a second time shortly after T plus 28 minutes and 38 seconds. So we'll see you back here at T plus 28 minutes.
No, that's it. All right, so they're booking it out for a minute. Huh. Ah. All right, well, I guess we wait to find out if the first stage landed, which I'm sure it must have, right? Must have landed, but we'll keep an eye on it. Hey, Tyler Matson, thanks for being a channel member for 12 months. Thanks, Tyler. Go Dart, thanks for staying up with us, Tori. Yeah, it's a late night. I don't know if I don't think I'm gonna stay all the way to deployment. I don't know. I'm not sure yet. It is kind of a late night, but we're gonna kind of see. They can't just leave us hanging, says Megan over on Facebook. Yeah, right. Yeah, I'm not sure what the deal is. I was hoping we'd see that. But somebody asked, there was a good question in here. Where was it? A lot of people ask why the transmission always fails. I mean, sending wireless video is surprisingly a lot harder than you think. Any little vibration in any of the transmission antennas, especially on the rocket or on the drone ship, depending on which camera they're showing us, you know, those vibrations can cause the transmitting signal not to make it to the destination, or at least not all of it to make it there. And in video, like, you have so much data being transferred and you need all of it, right? You can't just take little bits and pieces. That's how you get choppy or unreliable video. So you kind of need all of it. And so yes, sending video is a lot harder than it sounds, especially when you have, you know, something that's vibrating and has a lot of power to it. Let's see, what happens to the second stage after the payload separates? I believe this is a disposal orbit mission. So a lot of times they take the second stage and they'll put it into a, they'll bring it back in and burn it up into the atmosphere. But for this particular one, because it's going so far out there, I don't believe they published a re-entry hazard, which would mean that it's that it will go into essentially a graveyard orbit. Let me see, they didn't publish one. Yeah, there's no second stage re-entry hazard published. So this is going into a disposal or graveyard orbit, essentially. So it just stays out there forever. They'll move it out of the way, so it's not a harm to anything, or not a danger to anything. But yeah, it'll stay out there forever. There's lots of things that are like that you can go track on, like the Stuff in Space websites. Like, you can see pieces of second stages. I don't know if we can find one here, but you can find pieces of second stages that are, you know, from decades ago. I don't know if we can find one here, but sometimes if you kind of just poke around, like, here's a Ariane 5 rocket body from 1999. It's just out here in orbit. You know, you got tons of them that are out here. Some of them are in such a long period that they don't even show up in this tracking map here, but yeah, if you play around with it, you can find a whole bunch of them that are out there. All right, let's get, let's see, we don't need this anymore. We can get rid of that window. Found one the other night from 1978, says Christy Girl. Yeah, exactly, right? We find them, like I said, from decades ago, 1978, says Christy Girl. She found one from there. One of the the question was, I can't remember who asked it, was why does the altitude not keep going up even though the speed is going up? As the rocket goes up, right? I mean, a lot of times it's going to go up like this, but then eventually it kind of levels off, and you end up kind of burning. You're not burning horizontally anymore. You're almost burning like down a little, like pitched down a touch, and that's so that your perigee, which is the lowest point of that arc, or the oval or circle, is growing, but your apogee is not. So your apogee, the altitude that they're showing on the screen, is not growing, but your perigee, the other side of it, the shorter side, is growing. So you're trying to grow your oval right now. One side of your oval is in the middle of the Earth, and you're trying to grow that so that the side of the oval that's in the middle of the Earth is no longer in the middle of the Earth anymore. It's on the outside of the Earth so that you're in an orbit. Huh, they haven't showed us anything about the first stage yet, have they? Interesting. No confirmation of landing yet. Landed on the barge or maybe the water. It looked like it was going for the drone ship, so it didn't really look like there were any issues or anything. Seemed pretty normal. Just seemed like the video cut out, which is also kind of normal. Not really a big deal. Is this mission similar with the movie Armageddon? Kind of. I mean, well, what they're trying to do is they're testing the ability to redirect an asteroid by crashing something into it, right? So they're not bringing like nuclear weapons to blow it up into a million pieces or anything like that. They're just going to crash a satellite into an asteroid and try to change its orbit. The asteroid they're crashing into is not currently a threat to Earth. They're just doing it just because, so that they can test it. It's part of a binary system, 2 asteroids, one orbiting the other as it travels around. The big one is orbiting the sun and the little one is orbiting the big one, right? So they're going to crash into the little one that's orbiting the bigger one. They're crash into the little one and make it, instead of being in a big circle, it's going to be in a little circle, right? I'm oversimplifying, but that's essentially what they're doing. They're trying to change the orbital period of the smaller one around the bigger one and just change it. It just needs a tiny change. And the theory is that if we do ever discover an asteroid that might collide with Earth, that we discover it well in advance, and then you could do one of these missions and just give it a little tiny push, and then it would miss Earth, right? You don't need much. Like we don't need Bruce Willis out there with nuclear weapons blowing it to a million pieces, because realistically, if there's a satellite or an asteroid that size that's going to crash into Earth, we're going to see it years and years in advance. And all you got to do is just give it a little push out of the way. I mean, if it's enormous, the one in Armageddon is kind of enormous, right? But I mean, the ones that are a threat are the ones that are like big, like the size of the one that we're trying to redirect is the size of like 2 football stadiums, they said. So that's big. If that crashed into Earth, that would be a bad day. But it's not like, the size of North America. So it just needs a little push out of the way. Booster landing confirmed, says Anita. All right, perfect. Yeah, they're still playing music, so I can't pull it up. But let's see, could I mute this and unmute this? No, they're both playing music, so. All right, well. I still kind of feel like we shouldn't be redirecting stuff in space unless it's coming at us. Yeah, I mean, it is, you don't want to go pushing things all over the place, but on the other hand, you kind of want to test the process before, it's do or die. So this is the test of the process. They're trying to make sure that it's actually efficient, that it does what they think it's going to do, and maybe they have to make changes, and they gotta redo the Bruce Willis machine, or make changes to it. I think that's what we should call it, by the way, the Bruce Willis machine. But maybe they gotta make changes to it in order for it to be effective. That's something you don't want to find out when it's do or die. You want to find that out ahead of time. So it's kind of like driving a VW Bug into a skyscraper. Sure, kind of. Blowing an asteroid up has a lot of different problems depending on the composition of the asteroid. It's usually a bad idea. Yeah, the whole blowing it up into a million pieces is very complicated. That would be a disaster to try to control where the pieces go and things like that. So yeah, the simpler thing is just push it out of the way. Hey, Stay in your lane. Over there. Or actually, get out of your lane. Stay out of our lane. When will DART hit the asteroid? I believe it's about 10 months transit there. So it's not until, what is that, like September of next year when it's going to actually perform this operation. SpaceX tweet, stage 1 landed, 95th completion. All right, well, that's good to know. It's too bad that they haven't showed it to us, but they might show it to us come time for the next burn. So we do have the next burn coming up in about 28 minutes. I have these events out of order here, but that's okay. Fairing landing is actually at 38 minutes, which the time is correct. They're just out of order, but we can move those around. Nope. No big deal. Shift things around there. Why are there no Starlink launches at the moment? I'm not entirely sure, but I know that Starlink is having a lot of issues with the chip shortage that's going around. I'm sure you've heard of the chip shortage. That's been wreaking havoc on everything, all kinds of electronics manufacturing, whether that's chips that go into vehicles or into computers or all sorts of problems. But Starlink has been one of the casualties to this. At least I know the receiver end has been a casualty of this. So a lot of the beta testers that were promised Starlink terminals mid-2021 have now been told it's actually going to be mid-2022 now because they can't manufacture them because of the chip shortage. So I don't know if they're if the actual satellites themselves are also suffering from that as well. I mean, I imagine they got to be having some sort of problem. Yeah, blowing up an asteroid would make everything worse because of several thousand smaller rocks. Yeah, absolutely. That would be a disaster. Aren't the newer Starlinks upgrades to... Yeah, the newer... So we are done with version 1 Starlink satellites, and now they're launching version 2 Starlink satellites. So yeah, they have completed the first phase of Starlink satellites, and now, like, if we go to here, we can kind of see. Oh, does it not highlight them for me now? Starlink. There's too many. Oh wait, no. I just have to zoom in. There they are. Okay. These are all the Starlink satellites in orbit now. Like, look at that web they have woven around the planet. Like, that is pretty tight knit right there. It's pretty good. And then you have like two polar orbiting paths, 3 polar orbiting paths. Guess I didn't really realize that. But yeah, look at this tight knit web here. Like, you can clearly see how much coverage there is. Not so much on the poles. Sorry to the penguins and sorry to Santa, but it's coming. But the rest of the planet, like, looking pretty good on coverage for Starlink V1. Adam says he couldn't see the rocket in Imperial Beach. Oh, that's a bummer. I don't know where Imperial Beach is, but... Where is Imperial Beach? Imperial Beach, California. Let's see. Where is that in relation to, oh, that's all the way, like, south of San Diego. That might be... Yeah, I don't know. I guess I would expect that you'd be able to see it from there, but... It is surprisingly further east than I expected it to be, compared to where Vandenberg is. I mean, it is quite a ways to the east. Like, you're probably Imperial Beach is probably about 175 miles east of the launch path. So interesting. It was also cloudy in Southern California, says Steve over on Facebook. Well, that will definitely be a problem if it's cloudy. That will make it hard to see. Let's go back. I want to listen to the launch, although they're gonna do the second burn here in just a minute. But I want to listen to the launch on the other feed that I had that had the better microphones. Because we kind of cut those off because they were out of sync with the main feed. So, all right, we got that queued up. Let's wait, because they're gonna do a second stage restart here in 2 minutes. We'll wait for that, then we'll do a replay with the better microphones. And then I'm probably gonna end it. I'll probably end it after there. I'm not gonna wait for deployment. I gotta go to bed. I gotta fly my airplane tomorrow, and I can't be too crazy tired to fly my airplane, so. There you go. Graham says that Minitori explains Santa's powers very well. That's right. Minitori made an appearance on the channel last December to explain how Santa Claus works. So if you got little kids at home, and you want to explain to them how Santa Claus is able to deliver presents around the world like he does, check out our How to Track Santa video on the channel by Minitori. That was, I'm not really in the video, actually. He does the video. It's his video. He took over my channel. Oh, hey, look at that. We got a booster on a drone ship. Oh, they're still playing music. All right. Well, we got a landing out there. And it actually looks pretty well centered as well. It's kind of, I thought it was going to be a little off-centered when I was watching it come in, but it's looking pretty good. But there it is. They're finally showing it to us here now. Oh, and Jesse's back.
The Falcon 9 and the DART spacecraft in the desired orbit, and right now we are approaching the second engine burn, the burn of the second engine to carry Falcon 9.
There it goes.
Back ignition.
And back ignition. Quick burn. How long is it?
And there's that SES-2, as you can see live on your screen, lighting up there.
It's hot.
Now this burn is planned to last a little less than 1 minute. And during that time, we will add about 3.5 kilometers per second to our velocity. Now you can see the gauge on the screen showing stage 2 quickly gaining speed. We'll add about 3.5 kilometers per second, or about 12,500 kilometers per hour to our velocity. Again, this burn is the second burn for this mission.
I don't know what that
should be coming up here shortly.
It looked like it was. It looked like there was fluid leaking out of there, which was kind of odd. I don't recall seeing that before. But seems like a pretty
Invac shutdown.
nominal burn. Seco 2. It was 2 different angles. Maybe, yeah, maybe it was just catching the sunshine differently.
We heard that call out that MVAC has shut down.
But there you go. There's
now just waiting for confirmation of good orbit.
Nominal escape burn.
Yep, there's a nominal escape
and
burn. So
there
that's
is that confirmation of a nominal escape burn.
So escape velocity is about 40,000 kilometers per hour,
What that means,
which is pretty much
the
what it's
Falcon
doing.
9 second stage, with darts still attached, has escaped Earth's velocity. It's now in what's called a heliocentric orbit. It's circling the sun in an orbit that takes it from just inside the Earth's orbit to just outside, where in 10 months, the DART spacecraft and those 2 asteroids should arrive at the same time. Now, the DART spacecraft is still attached to Falcon 9's second stage, so we've got one more major activity remaining in the launch mission, and that is spacecraft deployment. It's timed to occur at about T plus 55 minutes and 42 seconds. So we're going to take another short break, and we'll see you back here at T plus 55 minutes for the DART spacecraft deployment.
All right, so there's that. We're in an escape trajectory here now. So escape velocity is about 40,000 kilometers per hour, which is pretty much what it's at now. Although you'll notice that it's slowing down, which is normal as it approaches. As the orbital period changes, it gets a little bit confusing because then you're questioning like what the speed is relative to. Everything is relative in space, but anyways, I wouldn't be concerned about the lowering speed is normal. I guess the thing to pay attention to is roughly how fast it's going, the fact that it's 40,000 kilometers per hour and the altitude is still climbing, which is good news. That's what we want. Okay, let's go. There you go. You can see that now. Let's go back to this view and let's play this back with the better pad microphones. Let's see, we gotta go to here, we gotta mute this one, go to here. Listen into this. I don't know where we are in the count here. It's only coming out of one side of my headphones, so if it's only coming out of one side of yours as well, then that's normal.
Falcon 9's in startup.
There we go. So that means we're about a minute away. That's about 1 minute.
Falcon 9, DART, go for launch.
There we go. So you got pad mics in your left ear, mission control audio on the right ear. Here's your headphone warning. It's gonna get loud.
T-minus 30 seconds.
Oh, I can hear the rumble. Listen to that. Listen to the rumble. Oh, we should have listened to this feed.
T-minus 15.
That's for sure.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Mission liftoff. Falcon 9 with the DART mission on the way for humanity's first ever planetary defense test mission. Vehicles pitching downrange.
Love that. Kind of lost it. That's it, huh?
Stage 1 chamber pressure is nominal.
Here we got a little bit of a rumble back. We got nothing to see, but well, nothing to see. So I'll show you this
Power and telemetry nominal.
while we listen to the launch. Anybody that jumps in now is going to be very confused.
Vehicle supersonic.
Oh, look at this view. This is a cool view.
Max Q.
Oh, you can hear a car alarm going off. Look at that view. That's a cool view.
convex chill has started.
Almost sleeping with this ASMR, yeah. Right? Kind of cool. Yep. And that's it. Okay, well, there's the end of that. All right, so, what were we gonna say? I was gonna say, I like to see the trajectory line going away from Earth. Yeah, that's kind of cool. You can see it in the escape velocity, escape trajectory there, which is pretty cool. Can you show the weird stream after SES2? Yeah, where was that? That was like, that was during the second stage burn here that we saw, right here. This weird streaming liquid here, it almost looks like liquid oxygen or something. Or, I mean, I guess it could be, RP1. I don't recall ever see, although it is directly in the sunlight, so maybe that's normal, but I don't know. I don't know why we would have, I don't know why that would be. Of course, I don't build rocket engines, so yeah, I don't know. It doesn't seem to have affected anything, obviously, but I don't ever recall seeing that little stream of, I mean, I suppose it could be ice or T-Teb, maybe? To put this into perspective, the ISS is 408 kilometers. This is already at 840 kilometers. Yeah, we are, yeah, let's go back to the live. Yeah, 873. So yeah, we're well above space station altitude. Where is it even coming from? Yeah, the streaming, that streaming liquid, it almost looks like it's coming from like the center of the engine bell, which would be weird because if it was fuel, like, I don't know, the engine is burning, so why would you get unburned fuel or oxygen coming out of there? Or is it coming out? I don't know. No, very strange. I don't know where that's coming from. I don't know what that is. I would love to know, though. I have no idea. Could it be ice crystals? It could, I mean, that's, like, it doesn't necessarily have to be liquid. It could be ice crystals, but I would have the same question, like, where is it coming from? Could be the locks from the vent port on the other side of the bell. Could be, it's just a weird, it was a weird place for it to be coming out. Maybe it's sunlight frying pixels on the camera, says Eric Burke. That could be. It's another possibility. Although it seems, let's see, go back to that. I mean, it is two different camera views, right? You had one and the other. I don't know, it seems, I don't know, it's so weird. Like, even if it, I don't know, first of all, which way is it going? Is it going, like, it almost looks like it's coming towards the camera, but that can't be possible. It's got to be going away from the camera. Which is really weird the way it's like messing with my perspective here. So yeah, it's I don't, and then it does kind of fade and go away a little bit. I don't know, it's weird. Look at the altitude, look at how fast that altitude is climbing. 2,000 kilometers already. It's going by real fast. I said I was gonna end it here, but I kind of like these views. Like, look at how fast it's climbing. What's the altitude at apogee? Well, it is no longer in Earth orbit, so it no longer has an apogee. It now has an apoapsis, or a what is it called? Like a... I don't know. Apogee specifically means the point above Earth, the furthest point away from Earth. So it's an apoapsis because it's now in heliocentric orbit, orbiting the sun. It's no longer orbiting Earth. So its altitude is no longer... So it's not... There's not really... I mean, at the moment, because it's still kind of leaving Earth, you can still give an altitude away from Earth, but because it's no longer aphelion, yeah, that's what we're looking for. Thank you, Lim. But yeah, giving an altitude relative to Earth is technically no longer like valid anymore because it's not orbiting Earth any longer. Like now it's orbiting the sun. So yeah, it's kind of things get weird when you get into different orbits. Could it be... It actually can be possible for the fluid to move in that direction. It appears to be. Consider angle of attack. Well, I don't think angle of attack necessarily... Well... Yeah, angle of attack is it's kind of a weird terminology to use for that, but... Yeah, I don't know. The perspective was weird. We're now up to 2,700, almost 3,000 kilometers now in altitude. 2,700. I guess flying by. Yeah, we haven't gotten to see the Earth get smaller since the Tesla Roadster, right? Oh, there's a little bit of ice or solidified oxygen breaking away there. Yeah, we haven't seen those views of Earth like that, so those live views in quite a while. Kind of forgot how cool it looks. This is very reminiscent of the Tesla Roadster. I said I was gonna end it and go to bed, but I guess, you know, now at this point, deployment is in like 10 minutes, so I might as well just wait it out. Yeah, this is a really cool view. How is there still a video feed? Well, it's surprisingly, I mean, they're still able to transmit back. I don't know, I'm not sure what they're using for transmitting that video back, but remember we had video views from like the Tesla Roadster for a long time. So, I mean, you just have to, you got to point it to your ground station. You'd still be able to get video, right? We can get data feeds from very far away. Just the farther out you get, the more delayed your live video is going to be. Yeah, I don't know. Somebody was talking about, are they using Starlink for this, for the video feed? I don't know if they'd be able to use Starlink for something that's going out this far, because Starlink is really in, I mean, this is well past the altitude of Starlink. And Starlink is really meant to serve Earth stations, so they may not have an antenna that kind of points away from Earth. So they may be pointing up to, like, what's the satellite network that I'm drawing a blank on? There's another satellite communications network that I'm drawing a blank on the name that they might be used, that's in geostationary orbit. Although they're getting pretty far out there. They may just have to be transmitting it back to ground stations, which as Sebi points out, it actually gets easier to do because you're going to be able to see more of the Earth the higher up you go. So you can reach ground stations a little more easily the higher up you are. Man, look at how this looks so cool the further out it gets. Always forget how cool that looks. It's so hard for Tori to end any stream. I know, right? This is cool stuff. I can't get out of it. I really do have to go to bed though. But we got 9 minutes until deployment, so we'll deploy it. I'll say bye, then I'm out of here. This is epic. These are really cool views. Like, it's a good thing they're showing us camera views and not just the map, because we're getting, just as I said that, we're getting a little shaky on the reception now. Would this work against a 1 kilometer asteroid? Well, I don't know what, I can't remember what the dimensions are of the specific asteroid they're impacting now, but they said it's about the size of two football fields. And so, yeah, I mean the theory is the same, kind of no matter the size. It's just the effect that you would have maybe a little bit less. I mean, obviously, if it's an enormous, like, you know, planet-size asteroid, like, you're gonna have a hard time moving that out of the way. But those are not usually the ones that we're concerned about. The ones we're concerned about are right about the size of, you know, like a stadium or like 2 stadiums or something like that, because they're big enough where they can really do some damage here, but small enough where they're hard to detect. Right? So we're constantly trying to detect asteroids that are out there, but you know, we can detect the big ones. The big ones are the easy ones to detect. It's the little ones that are the hard ones to spot. And by little, I mean like real little, like we don't care about. If it's like the size of a rock that you can fit in your hand, well, that's gonna burn up in the atmosphere if it comes their way anyway, so no big deal. But something that's the size of a couple of football stadiums, like, that's not gonna burn up in the atmosphere. I mean, it's gonna try, but it's gonna get through. It's like hitting the snooze button twice, Tori. Yeah, I do that too, so maybe that's my problem. Yeah, well, I guess we're gonna wait for deployment now. We're only 7 minutes away. I wasn't gonna do this, but the views are too nice. Crazy to think that the Roadster was launched 3 years ago, right? I mean, almost, what was it? Like, it was 2018. That's almost 4 years ago now. And that's when the whole
Lobster Fest is on.
That's when Space Lobster started. 2018. That was almost 4 years ago. February 2018, right? Crazy. 3 years and 9 months. Yeah, we're getting pretty close to 4 years. Where will the second stage go after deployment? It's just going to be in it's going to be in heliocentric orbit. So it's basically in a graveyard orbit. It's just going to be out there permanently, along with a whole bunch of other things that are permanently out there. But yeah, it'll just be in a permanent heliocentric orbit. Not really going to affect us here on Earth any longer, because it's going to be in, such a long orbital period that, it's probably rarely ever going to come near Earth ever again. It'll come somewhat near Earth, but yeah, by the time it gets out there and makes a couple of trips around the sun, it's going to be out of sync with the Earth's orbit, and we won't see it very often. So yeah, it'll just be out there. Second stage will maybe visit Starman. Yeah, it's not quite. I mean, you got to remember, space is a really, really big place. And they're not even going in the same direction, so the chance that Starman meets up with the second stage here are pretty slim. In fact, I would say 0. Not just pretty slim. Pretty slim is too optimistic. It's 3 a.m. here in the Caribbean, so you're not the only one up late, says Jeff over on Facebook. Yeah. We're just waiting. We're 4 minutes away from deployment, and then we're going to call it. Did you mean OneWeb? No, OneWeb's not the one I was talking about. See if I can find it here. What was the satellite? Iridium. That's the one that I was looking for. I guess they're not in. That's not geostationary. Iridium was what I was thinking of, but they're not geostationary. Now that I recall the actual name. So I don't know what they're using to they must be transmitting back to ground stations for that video. It's gotta be. Because I don't think you'd be able, I don't know of any satellites you'd be able to transmit to for communication at this point, now that it's 6,000 kilometers in altitude. But Iridium was the other constellation I was thinking of, but now that I've got it, that makes no sense, so it's not that. Could maybe TDRS. The tracking and data relay satellites, the TDRS system, that's geostationary. But yeah, even now it's I mean, it's so far out there now, 6,100 kilometers. It's getting up there. I mean, it's still within geostationary orbit. What's geostationary orbit? Geostationary altitude's like 35,000 kilometers. So yeah, we still got a ways to go. Especially, it's interesting to think how far away geostationary orbit really is. But yeah, 35,000. So really, the only communication network you'd really be able to work with is in geostationary. So why is speed slowing down? Speed gets a little bit weird, but it's slowing down relative to Earth because it's climbing to an apparent apogee, although it's not really in Earth orbit anymore. Now it's in heliocentric orbit. So speed gets kind of weird because speed is all relative. So that speed is relative to Earth, and it's no longer in Earth orbit. So, hey, my friend Marcus House. What's up, Marcus? This has got to be the middle of the day for you. It's like, I need to go to bed here. But Marcus says, victory. That is a nice view right there. How you doing, everyone? Yeah, everybody say hello to Marcus House in the chat. Marcus is, I said it before, but I'm going to pump his tires again and say that he's genuinely one of the nicest people in the YouTube community here. Yeah, it's super awesome view. I love this view. It's very, we were mentioned it earlier. It's very reminiscent of the Falcon Heavy Tesla Roadster launch. Gives me, kind of gives you those flashback vibes of what it was like watching the Starman and the Tesla Roadster with those views of Earth behind it. It was pretty crazy. So we should be coming up now, pretty much right now. Let's see, let's go to this, oops, no, here. So deployment should be in 1 minute here now. Let's see, let's get this unmuted. Still playing music.
To our launch coverage of the DART mission for NASA.
Here we go.
If you're just joining us, we had an on-time launch at 10:21 p.m. Pacific time, followed by successful ascent stage separation, First stage landing took a little bit, but we got the pictures. And it's 2 second stage engine burns that have put DART on an escape trajectory from Earth. There's one more major milestone coming up to complete today's mission, and that is deployment of the DART spacecraft from the Falcon 9 second stage, due to happen in about 10 seconds from now. The view you see from the second stage camera is the DART spacecraft. We're gonna listen to hear the call out and watch for DART separation.
Should be pretty much right now. Supposed to be at 55.
DART separation confirmed.
Boom! There it goes. And it's away. That's it.
And to those watching, you're witnessing a successful deployment of the DART spacecraft. The impact of the DART spacecraft with the small asteroid Dimorphos is scheduled to happen sometime between the end of September and early October in 2022, when the double asteroids are closest to the Earth. Now, during impact, the spacecraft will be traveling roughly 15,000 miles per hour or 4 miles per second. This is going to be an exciting collision to witness, and we wish everyone at NASA the best of luck with the rest of the mission.
Oh,
Those are some incredible views there. Now, one quick clarification. This is actually the 95th recovery of a Falcon first stage, which is the 88th for a Falcon 9. And with successful payload deploy, that brings our webcast to a close. For continuing coverage of the NASA mission, head on over to nasa.gov/live or check them out on their social channels. Thank you to NASA for entrusting us with the DART mission, as well as the range for their support. And of course, thank you to all of our viewers. We hope that you enjoyed the webcast this evening, and we'll see you again soon.
All right. Well, there it goes. The DART mission is away. 10 months from now, it'll meet up with the asteroid, collide with it, 15,000 miles per hour. See if it can change its orbital period just by a tiny little bit. And then we'll find out how the mission goes. But yeah, we still, how long until we get video? Yeah, so it's going to take 10 months to get there. So we've got a long time before the actual mission happens. But don't worry, I'll remind you for sure. We'll make sure that everybody is in the know for when that's taking place. So, all right. Anyways, I think that's going to do it for me. I mean, we talked a bit. I think we answered a whole bunch of questions. Thanks again to everybody for joining us here today. Thanks to my friend Marcus House for jumping in the chat for a little bit. Love when our YouTube friends jump in along here. He said a little while ago, in reaction to my mention of the Starman, that it was reminiscent of the Starman days. He said, indeed, there were some terrific Starman views similar to this. Awesome to see. We don't get to see missions ejecting Earth from SpaceX very often. Yeah, leaving Earth's orbits. This is pretty cool. It's pretty awesome to see some of those views today. So. All right, well, I'm gonna head out here and end it. I'm gonna kind of end in a bit of a hurry. I gotta fly my airplane tomorrow. Hopefully, if the weather's good, I'm gonna try to fly the airplane, get a little more practice in. If you wanna see how that's going, or chat it up some more about space or SpaceX, or if you wanna see what I'm doing with my my airplane piloting skills, feel free to join our Discord, and you can chat it up there. I'll give you updates about whether or not my flight is happening tomorrow and what I'm going to do. You can we'll chat it up some more in Discord if you want. But yeah, other than that, if I don't see you on Discord or we don't talk to you soon, if you're in the U.S., happy Thanksgiving and enjoy time with your family. If you're not in the U.S., well, I guess happy Thanksgiving to you as well. Why not? Enjoy your Thursday. Happy Thursday to you. But we've got the Thanksgiving holiday here coming up in the U.S. on Thursday. So. All right, that's it. I'm leaving. I'm going to bed. I said I was doing that like 30 minutes ago, so. All right, thanks everybody for watching. Thanks for hanging out with me today. My name's Tori. This is Overlook Horizon. I'll see you next time. Have a good rest of the day, everybody. Goodbye.